What's going on, everyone? Welcome back to the channel. Today, we're going to be working on struct declarations, mainly properties, and struct instantiations, as well as array literals. We are then going to also really quickly work on array types. So in the last episode, we were able to get this parsing right here. And let's just prove it, like so. And we can see in the variable declaration, assignment true, the assigned in value, and then what the expected type is an array of number, right? But I mentioned in that video how you could also pretty easily change this parser syntax to support types like this, similar to how TypeScript does it. So let's just quickly demonstrate how that's done. And of course, we get expected assignment but received open bracket instead. So let's quickly tweak the parser for the types, just so we can see how easy it is to modify the parser to suit your own style of syntax. So I'm going to Control Z, I'm going to copy this, I'm going to create a new file, 05.lang. I'm going to paste this in here, and then all I'm going to do is I'm going to try to get it so it can parse this, like so. I'm going to go into the main.go, change this to say 05.lang, right? And then let's go into the types.go, and basically what we're going to do is we're going to add a lead handler. Sorry, not this one, a lead handler for the open bracket. So if we take a close look at this, right, the type T is a nud, right? We already know that for a fact. The type T is a nud. It's an identifier. It's handled on the left. However, then the next token is a left bracket. Therefore, it has to expect the type to the left of it. So this is going to be a lead handler now. So I'm going to change the parse array type to be type lead, which means we're going to take in a call, and it's going to yell at me because it's going to say this is not a type lead. Currently it isn't, it's a type nud, right? So what we're going to do is we're going to take in the left, it's going to be an AST.type, and then we're going to take in a BP, which is binding power, like so. And now all we have to do is I'm going to just change this text to say expect lexer.open bracket, just so it's nice and clear. So either way, we advance, right, past the open bracket and the closed bracket, and then we've already parsed this thing to the left. So we actually don't have to do anything here. We just simply type in left. And there we go. This is how we can switch the syntax around to support this type, right? So it's the exact same tree as this. However, we've changed it so now this is handled via a lead handler instead of a nud. So this is the exact same as this. If we just tweak this a little bit, right? Control Z a little bit, and there we go. Again, same tree, same thing. But yeah, I just wanted to show that so you know that it is absolutely possible to tweak the language syntax however you want. You don't have to do exactly what we're doing in this series. The whole point of pratt parsing is to make it very easy to tweak your syntax without screwing up a lot of things. So I hope you found that useful. Now what we're going to do is we're going to continue, and we're going to eventually be able to parse stuff like this. So struct, let's just call this a shape. And it's just going to have a, or let's just call this a rectangle, rects, we'll call it, sure, that looks good. It's going to have a width, can I type? Thank you. Width, which is a number, a height, which is a number, like so. So this is what we're going to be parsing today. And then we'll also be able to do const foo equal, or const r1 equals, and then we can do rect like this, and do width of 10.2 and heights 45.2 plus 10. I don't know. I'm literally just spitballing stuff, right? So this is a struct declaration, and this is going to be what we call a struct instantiation. And then later we'll also support this. So numbers equals an array of number. And then we're just going to do 1, 2, 3, 4. Right, so I'm going to take inspiration from Go because that's the language we're writing this in, so might as well, right? And we're going to have syntax such as this. So we specify the type in between the bracket, and then we can also specify an optional size. But I'll leave that as a challenge to you. And if people are having a lot of issues, I'll cover it in a later episode. But so right now, I'm going to just comment this out. And I'm going to, for some reason, comments don't work. I'm going to just really quickly change this to be, it's really annoying. Whatever, I'll just delete this. And let's get this working. So the declaration, right? If we run this, we're going to see expected semicolon, but received identifier instead. What does that mean? Well, currently, I don't think we have a struct keyword. Interesting, right? So let's kind of see what's going on here and see if we have a struct keyword. So let's go into the lexer. Let's go to tokens go. And clearly, we do not have a struct keyword. Unfortunate. So let's come down here and type in the word struct. And let me make sure we don't need anything else. In the future, we might need a static keyword as well. So there we go. I'm going to add those two. I'm going to then copy these. And we're going to change this to be struct, static, and static, and struct. There we go. So now it's going to yell at me for a different reason. It's going to say nut handler for token 50. What does 50 mean? Well, 50 is this. So we need to add this to our printing, like so. So I'm just going to copy these two because I'm kind of a lazy typer, as you can tell. And this is going to say struct. And this is going to say static. There we go. There we go. Nut handler expected for token struct. So let's go ahead and implement this. This is a statement, hence why there's no semicolon at the end. I don't want to have a semicolon like C++. It looks kind of weird. So what we're going to do is we are going to minimize the types file. We're going to go into the AST, go to the statements, and we're going to create a new statement. So we're going to do type struct statements. And we could call it like struct decl, like declaration statement as well. I don't really know which one I prefer more. I'm going to go with this. And we're just going to do n struct decl. And then this is a function called stmt. And I don't know why I'm typing the word func there. There we go. Cool. So what is a struct? Well, a struct, first things first, it contains the name. So that's probably important to know. Is a string, right? I mean, clearly, it can't be anything else, right? We can't like put an expression here. And then it contains an array or a map, however you want to do that, right? It contains a mapping of properties. Now, Golang does not do maps in order. So depending on if you want to make sure that things are defined in order, which you probably do, you might want to use an array here. So what I'm going to do is I'm going to create a type called struct field or property, and this is of type struct. Help, thank you. Perfect. And what we're going to do is we are going to give it a string, property, which is a string, right? The actual name of the property, and the type, which is, of course, just type, right? So every property is going to have a name and a type. And I'm also going to add a Boolean for is static, which we are not going to deal with right now, but this will determine whether the property is static, right? An example of this would just be if we simply typed the word static here, right? Or pub, or you get the idea, right? So we can add these modifiers like this. Same thing for later. We'll have function, right? Like foo, and it'll be able to do stuff like self.height equals 10, whatever, right? But then we'll also have static, something like new, which maybe will just return a self, right? And it'll just return a rect. you get the idea. So this would be a static function, while this would not. So we're not going to implement this right now, but in a future episode, mainly once we do function declarations, then we'll come back and do function methods for structs, because they'll use a lot of the same code. So for now, we're just not going to bother with this as static. It's just going to be false by default. So what is this going to take in? Well, it's going to take in the struct property. What we're going to do is we're going to do a properties is a map of string to struct property, like so. And there we go. So this is going to be what we are doing. In the future, what we'll also do is we'll have a struct method. And in fact, let's just create it now so we don't have to worry about it later. And this is going to be struct method. And we're going to also have is static. We're going to have, technically we don't need the name for either of these. I mean, it's a nice little nicety, so I'm just going to remove it. But we don't need the name. And then here we'll have the type being a function type. But for now, we haven't implemented that, so let's just kind of comment that out. And let's just add the other thing we'll need, which is methods, which is a struct method. There we go. So this is a struct declaration. It's going to have the struct name, properties, methods, and again, maybe you want to have a public keyword or something like this, where this specifies that this is available outside of the module. Well, to do that, you basically are going to need to have a thing here. So you're going to need to have a public bool, right? Which for now, I'm not going to deal with that. That's something up to you if you want to do that. But yeah, so for now, let's get this parsed, right? So we have our type like so. So what we're going to do is we're going to head over to the parser. We're going to head on over to the statements, and I'm going to minimize variable declaration. I'm going to create a new function, parse. Parse struct declaration statement. Again, it takes in a pointer to a parser and returns an AST dot statement. And at the very end, we're just going to do return struct declaration statement, like so. So I'm going to, in here, I'm going to create a couple variables. First things first, we're going to need the, I'm going to do p.expect lexer.struct. So this is advanced past struct keyword, right? Then we're going to create some variables. We're going to have the struct name, which is going to be parse, p.expect, and this is a lexer.identifier dot value. So we're expecting an identifier, and then we just get out the value. That gives us the name. So if we find the struct keyword, we then expect an identifier, right? We're also going to need two other variables. We're going to need the properties, which is, of course, a map of string, right, to AST dot struct property, like so. And I'm going to copy this because we're also going to have methods, right? Is map string struct method. There we go. So these are the three things we kind of need, right? Property, name, methods. So down here, I'm going to do properties is properties, methods is methods. Oh boy, there we go. And name is name, like so, right? So there we go. We basically have everything we need. Now we just need to actually implement the parsing for the structs. So first things first is we clearly expect an open curly and then a closing curly to terminate this. So let's just add that, right? So p.expect lexer.open curly, and then at the very end we do p.expect lexer.close curly, right? So that's clearly going to support these two pieces right here. Now, what do we do? Well, there's a number of things we can have in here. We could have properties, we could have methods, etc. And they're all terminated by semicolons. But we don't know how many we might have, right? We may have 2, we may have 0, etc. So what we want to do is we're going to want to for while the p dot has tokens, right? So while we are not at an end of file. And then while p dot current token kind is not equal, right? Is not equal to lexer.close curly. So while this is true, we basically want to build up this. And the way we're going to start is if we see the function keyword, right? then we're going to be dealing with methods. If we don't, then we're assuming we're dealing with properties. And this will change once we get to the static, like this, right? But for now, we're just going to deal with this. So if currently, we're just going to assume that there's no such thing as methods for now. So we're going to do if p dots current token kinds is equal to, you know, actually, while we're at it, let's just add the static. It doesn't hurt anybody right now. So we're just going to add the static right now. So first things first, if the current token kind is static, right? So lexer.static. Then real quick, I'm going to just add a var is static is a bool, right? And we're just going to say is static equals true, right? And then we're going to also need to eat that token. So we're going to do p dot expect lexer dot static, right? So this is going to eat the static token. Cool, nifty stuff. So now we've already basically handled the static. Very exciting. So I guess I'll leave it in here. Right, so this should now be able to parse. Okay, cool. So what we want to do then is we want to check if p dot current token kinds is equal to lexer dots, and what we want to check for is we want to check that it is an identifier. Right, so identifier. If it's an identifier, then this is clearly a property. Right. If we make it here, then I'm going to just panic and say cannot currently handle stat methods. Right. Methods inside struct. Okay, cool. So if we make it to an identifier, right, clearly that is the name of the property. So what we're going to do is we're going to create a couple of variables up here. We're going to do var, which is also a string, right? So we're going to just say property name equals p dot expect, and we're going to do lexer dot identifier dot value, right? So this is going to pull out the property name. Cool. Now we expect a colon following the property name. So we're going to do p dot expect, and we're going to do lexer dot colon. And then here I'm just going to say expected to find colon following property name inside structs declaration. There we go. Magic, right? Cool. So now we've encountered the name. We then encounter this. Now we just need to parse the type and expect a semicolon, right? So we're going to do var type, we can't use the word type. So we're just going to say struct type colon equals parse type, pass in the parser, and we have a default binding power because really any type is fine here. We can have a number array or a number array or whatever, right? It doesn't matter. There we go. So that's the type. And then we just want to do p dots expect lexer dot semicolon, right? My language, I want structs to be denoted with a semicolon. You may use a colon. You may not use either of those and actually just continue parsing. I think it looks weird though, so I like to have semicolon terminating the end. Cool. Now that we've constructed all of these, right, the static, property name, struct type, etc., we can now construct a property, right? So we're just going to do properties of, I guess one last thing we can do is let's check to make sure a property is not duplicately defined, right? So currently there's width and there's height, but we don't want to allow two widths to be defined. So we can just do colon exists colon equals, and we can do properties of property name. If it exists, then we can panic and say fmt.sprintf property %s has already been defined in struct declaration, and then we can just pass in the property name. Right, like so. Cool. If it does not exist, then we can continue and define it. So we can do properties of property name is equal to a struct property where we have a few things. We have whether we're static, which is static, the name, which we don't hold on to anymore, and then the struct type, which I think we just called type. Yes, we do. And there we go. That's it. So now we can call continue like so. Because in the future, we'll have another if check over here for whether we're at the function keyword like so. So for now, I'm just going to continue, and it's going to allow us to keep iterating through this loop. So let's double check that this works. First, there'll be a function, right? So let's double check. Oh, I have to call this handler, right? So currently there's no nut handler for struct, and that's to be expected, right? So we've created the function parse struct declaration statement, right? But now we need to actually instantiate it in the lookups. So down here with statements, we're going to do stmt lexer.struct and call it like so. And there we go. So now we get cannot currently handle methods inside struct declaration, which is because we have this, right? So let's just double check that this works. And there we go. Look at that. So we can see that height is a static property. It is true. The type is number and also number. We can see there's no methods because, again, we don't support them yet. And look at that. We can tell that if we add another property, like let's just call it width of string, etc., it'll yell at us. Yep, property width has already been defined inside struct declaration. So that's really exciting. We now have the ability to add static and non-static properties inside of structs. So now let's go ahead and actually get started with the instantiation part. Right? So let's say I want to instantiate one of these struct members like so. We can come in here and do const s equals, let's just call it square equals a rectangle where the width and height are both the same. Help, I cannot move this for some reason. Right. And we expect this to work like so. And I'm going to just drop these onto new lines. There we go. Cool. So let's see if we can get this working. And we run this, and we get expected semicolon, but received open curly instead. Fascinating, right? And the reason is because it's currently thinking this is an identifier, right? So what we're going to do is we're going to add a lead handler for an open block, like so. So let's head on down to the expressions.go, and let's add a new AST type, right? So we're going to do type. Struct instantiation is a struct, right? And what we're going to do is we need a few things. First things first, we need to know the struct type, right? So we're going to do struct name, which is a string, right? And then we need to know the properties which are being defined, right? So property, which is an array of, well, what is it? It's an array of key value pairs, right? So I'm going to just call this a type of struct. Actually, we could, I mean, there's a couple different ways we can do this. For now, what I'm going to do, though, is I'm going to define this as a map of string to expr, like so. Okay, perfect. So if we look at what this is, it's going to be a map of string to the actual instantiation method. Now, there's a few things to note here, and I do want to mention this. In some languages, maps are order agnostic, right? So the order you define things in is the order they're actually going to be displayed in or iterated over. That's not the case with Go. Go, I can define width, and then height will actually show up first. In fact, I think we actually saw that in one of our examples. Yes, height showed up first, then width, even though clearly it was the other way around, right? This is pretty important depending on how your language's semantics work. For ours, it won't really matter. And when we get to type checking, it also won't really matter. But I do want to mention that depending on what you want with your language, again, I can't tell you what you want. You may not want to use a map. Instead, you may want to use an array, which will be order independent, right? So for now, this is a struct instantiation. I'm going to copy this method. And then we're just going to struct instantiation is an expression now. Perfect. So there we go. Now all we're going to do is we're going to go over to the exper.go. right? The expressions here. And we're going to, underneath parse expression, parse prefix, parse grouping, and parse assignments, we're going to come in here and we're going to do parse struct instantiation. And it takes in a pointer to a parser. And this is going to be a let handler. So it's going to take in a left, which is an ast.expr, and a bp, which is a binding power. There we go. Cool. Okay, so this is a instantiation. Why am I expecting something to the left here? You may be asking. Well, clearly, right, when we were parsing this, it parsed an identifier, right? And then it parsed this token, right? Which means clearly this is only valid if something is to the left of it. So this is clearly a LUD, or LED token, right? So that is why we expect something to the left. When we parse this, we'll have the left, which will be the struct name, which is pretty cool. Perfect. So what we're going to do, first things we're going to do is we're going to check to make sure that the left, first thing we're going to do, okay, let's edit this one. Okay, the first thing we're going to need to do is we're going to need to make sure that this left is indeed a identifier, right? So this is actually something that we're going to not use. I mean, you can easily do it in some languages in Go. I'm going to use reflection to do this. So we could do like a switch on the left dot type, right? And if it is a symbol expression, then we can say var, what is it? Struct name is a string, right? And then in here we can say s : equal, and then just do struct name equals s dot value, right? Like we could do this, and then we just need to have a default where we panic, right? Expected struct name inside struct instantiation, right? However, this is really annoying and it's kind of ugly, right? I mean, it really is kind of ugly. So what I want to do is I want to create a helper method, which I'm going to create inside of a folder called, let's just call it helpers, I guess. And inside this folder, we're going to create a file called reflection.go, which is in the package of helper. And basically what I want to be able to do is I want to be able to call a function like if not types, or we can also just do right, struct name equals helpers dot expect type, and then we would pass in something like ast dot symbol expression, and then pass in left, and then we can do dot value. Right? This is what we're going to get parsing in today. So what I want to be able to do is, oops, I need to do equal right there. Okay, so by the end of this, I want to have a function called expect type. It takes in a symbol expression, right? And then it gives us a left-hand side value, right? So let's actually get this parsing right now. So let's head on over to the reflection and let's create this function. It's going to be called expect type, right? It's going to take in t, which is anything really. I mean, we could say it's an expression or whatever, but for now we're just going to say it's anything. And then r, which is also anything, right? So what did we receive is why I'm calling it r. And then it's going to return that type right there, right? So what we want to do is we want to get what the expected type is in terms of the reflection. So we're going to call it expected type. And this is a bit complicated if you've never used reflection in Go. So we're going to use the reflect library. and we're going to do type of. So sadly, we cannot just pass in t. That doesn't work. But what we can do, and this is kind of tricky, is we can pass in a pointer to a t, and then we can give it a value of nil. And what this is going to do is it is going to know the type of this is a t pointer, which means then we can do lm like so. And this is going to be a type, which we can now work with. And then we can do the same thing for the received type, which is a little bit easier. We could just do reflect.type of r, like there. And now what's really cool is we can compare these two, right? So if expected type is equal to the received type, then we can just return rt, like so. And there we go. So there we go. This now handles this case. However, now we need to panic if we didn't find one, right? So panic fmt.print, not printf, fmt.s printf, and let's just say expected, expect, expected, but received instead. Again, you can make these errors a lot better. For example, you can pass in additional error things. You can have a function which just returns the Boolean instead of if they match. There's a lot of little things we can do here. I'm trying to keep this language series as simple as possible. So I am not going to be adding really any of this, right? So, and these won't be D's or strings. I forgot these will be T's because we don't know what they are, right? We'll use goes reflection to do this. And we'll just say expected type, received type, right? There we go. So now we have an expect type function, which can automatically infer and do the casting for us. So there we go. Now it knows this is a string and that it's been casted, like so. Okay, so that is the struct name handled, right? So now what we're going to do is I'm going to go look here. So we've handled the struct name. Now we expect an open block and a closed block followed by a semicolon. Actually, we don't expect the semicolon, sorry. So let's now handle that. So let's do expect lexer.open curly, and then p.expect lexer.close curly, like so, right? And there we go. So now what we want to do is we want to create the map. So it's called properties equals a map of string to expert, like so. And there we go. So now what we want to do at the very end is just to return struct instantiation, and we're going to call it the struct name is the struct name. And the, I literally already forgot what we called it. We called it properties. Good. Properties. Nice. I love it when I can't spell things. There we go. Properties. And properties is, of course, properties, like so. There we go. Okay, so now that we've handled this, let's now handle the inside of the curly brackets, right? So what we want to do is for p dot has tokens and p dot current token kinds is not equal to the lexer dot close curly. And while we have tokens, right? So while we are not at the closing curly brace right here, we expect a property name followed by a colon followed by a value, right? So we'll do var is equal to parse p dots expect lexer dot identifier dot value, right? So this gives us the property name, and then now what we want to do is we expect the colon, right? So we expect the colon. So lexer dots not lexer, sorry, p dots expect lexer dot colon, and then now we expect the whatever this is. This could be a number. This could be a type. This could be 10 times 2.5 modulus foo, right? Like this could be a complex expression in here. So what we want to do is make sure that this is an expression. So we're going to do expr colon equals, and I'm going to also not mix and match my syntax. Let's just do this. Expression equals a parse expression, pass in a p, and then we have to define what type of binding power goes in here. Now, I don't really like the idea of saying x equals 10. That feels kind of weird. So I'm going to make it so the binding power, the minimum binding power we can pass in, is going to be a logical, right? I don't want assignment binding power. That's kind of weird to me. So we're going to say that this cannot be an assignments. It can be logical though. Right? And that's all we have to really do for that. There we go. Now we have the property name and the expression. So we can do properties of property name is equal to expr, like so. And then we just do if p.current token kind is equal to lexer.close curly, then we can, if it's not equal, I think would be an easier way. If it's not equal to the close curly, we do p.expect lexer dot comma, like so. And there we go. So now if we test this, we should see that this will yell at us because it won't work. So let's just quickly do a 10. Okay, expected a semicolon but received open curly instead. Am I forgetting to set it up in the lookups? I'm pretty sure I am. And I am. Okay, so currently this is a lead, right? So these are going to be where we define our col/member. And here we're going to define a lead for lexer dot the word struct. Oh my god, I cannot type. And then here we're going to pass in the binding power of col, and a lead is going to be parse struct instantiation, like so. And now if we run this, expected semicolon but received open curly instead. Yeah, my bad about that. It is not a struct, right? We're looking for the open curly. So lexer.open curly is a lead. And there we go. So let's take a quick look at this and just make sure this looks good, right? So we do a struct declaration, that looks fine. Then we do a variable declaration where square is constant, where the assigned value is an instantiation, where the struct name is rect, and the properties are height and width of 10 and 10. But you can imagine how we can also pass in another struct instantiation, right? I mean, we could say foo of bar is, this is a, right? And there we go. And we can run this and we see that the width property is a struct instantiation of foo. Now again, we're not doing type checking, right? This is 100% not valid, right? There's no foo property. Width is not a foo struct, whatever that may be. However, that's something you do later, right? I mean, we could technically start doing type checking right now, like inside of the parser. But typically I like to do type checking outside of the parsing stage. And yeah, so we were able to test it without a trailing semicolon, right? Let's try it with a trailing colon. And we're not like JSON. We allow trailing colons if you want to put one. So there we go. These are struct declarations and struct instantiations. Now we're going to finish today's episode off with a really easy one, and this is going to be array literals. So I'm going to just say numbers equals array of number, like so. And let's just do 1, 2, 3. So let's test it, and surely we get nut handler expected for token open bracket. So let's test this out and let's get this fixed. So what we're going to do is we are going to go ahead and go to the AST. We're going to go to the expressions, and we're going to copy this because we have a new expression to add. And this is an array literal, like so. Perfect. It's magical. So first things first, we need to know the underlying type, right? Array literal or array instantiation. They're both kind of valid. I'm going to call it array instantiation. Perfect. So the first things first, we need to know what the underlying type is, right? So this is an array, clearly, of something, right? In this case, it's number. So we're going to add that. So we're going to have an underlying, which is of type. Nice. Okay, cool. Next, what we want to do is we want to have the instantiations, or the list, right? The body, the contents, as it's called. So contents is an array of expressions, right? Hopefully they're all the same type, but if your language doesn't support static types, then, and you don't want to do type checking, you want it to be like JavaScript or Python, etc., where you can mix and match types, then this is what they are. It's an expression. Here it could be 1.5 times 2. Here it can be like, you know, a. You get the idea, right? So these are expressions like so. So for now, I'm just going to do 1, 2, and 3. Cool. Okay, so let's quickly go ahead and get this parsed. So let's remove the helpers. We're done with our expression here. So contents is an array of expression. Let's minimize the AST folder, minimize this, and go into the expression go. Minimize struct instantiation. I'm going to create a new function called parse array instantiation expr. P is a pointer to a parser, and the question is this a led or a nud? And I want you to really think about this, because seriously, once you get the hang of this, I think you'll quickly see that you can write a parser for basically any syntax very quickly if you just think, what token means what? Well, clearly when we reach an open bracket, there doesn't have to be anything to the left of this, right? I mean, we can just remove it. Like, clearly there's nothing to the left of this required. So this means it's a nud, right? So this is a nud, meaning we don't need a left or a binding power. So it's return an AST.expr. Let me just return a array instantiation expression, like so. Oh, I want to call this array instantiation expr. Did I do this here as well? Struct instantiation expr. I definitely want to make sure I'm calling it that. I like to add the word expr to things that are expressions, and stmt to things that are statements, right? And I think I do it here. There we go. Okay, perfect. Sorry about that. I just want to make sure we're keeping it consistent, right? All of these have expr because they return expressions. Okay, cool. So now that we've done this, right, what do we need to do? Well, there's two things we need, right? We need to know, sorry about that. I am failing right now, so bad. We need the underlying type and we need the expression. So first things first, let's create a variable for those. And this is going to be underlying type. And this is going to be of type ast.type. And then we need to know the var, the body or content, which is an array of equals array of ast.expression, like so. And this is basically how we want our syntax to look, right? I mean, literally I'm modeling it just after Go because I really like Go syntax for this. And then at the very end, we just return underlying is underlying type and contents is contents, like so. Perfect. So let's now quickly parse this. It should be pretty straightforward. First things first, if we encounter an open bracket, we should expect to parse it and then the closing bracket. So we do p.expect lexer.open brackets, p.expect lexer.close bracket. Now, I will put in a comment if you want to have sizes here, then you will need to handle that instead. So for example, if we expect an open bracket, right, and the token that's inside this is not a closed bracket, then you'll need to parse a size. Like for example, we may say this numbers array is initialized to 10 length, right? But for now, I don't want to support that syntax. You can if you will. It's just a slight tweak. A few more lines of code will need to go right here before you parse the close, right? So now what we're going to do is we've parsed the open and close. Now we expect the underlying type. So that's what we're going to do. We're going to say underlying type equals parse type. We're going to pass in the parser and give it a default binding power. Perfect. So that now handles this. I mean, again, it could be an array of numbers, right? I mean, that is 100% valid of what this syntax could mean. So therefore, this could be a complex type. It's not just a string or an identifier. Lastly, we then parse the body, right? So what I'm going to do is I'm going to go ahead and do this, right? So what we're going to do is we are going to, first things first, for while p dot has tokens and p dot current token kind is not equal to lexer dot close curly. And I don't think I parsed the initial curly. No, I didn't. So let's do that, right? So we do p dot expect lexer dot open curly, right? So we expect an open curly, which means we also expect a p dot expect lexer dot close curly, right? So we expect an open curly and following a closed curly. However, in the meantime, while there is nothing in the curly, we do expect at least some data, right? We could have nothing, but if we have anything, we expect a comma-separated list, right? So first things first is we get out the expr. So expr colon equals parse expr. We pass in the parser. And again, I do not want to have assignments in here. I don't know why people like this kind of stuff, but I don't really like this idea. Yes, this will get assigned the value of 10, and then it'll also put 10 in here. I don't like that. I think that's kind of tacky. So for this, I'm going to say it has to be another logical expression. So let's just do that. So this has to be a logical expression, like so. And instead of just creating a variable expr and then immediately parsing, putting it into the contents, I'm going to switch this up. I'm going to do contents equals append parse expr p comma logical, like so. So this just kind of alleviates that line. Lastly, we need to check if there's one element, right? Or if there's two elements. We don't require a trailing comma, just like we don't here, right? So we need to check if it's the end. If it's not the end, sorry, p.current token kind is not equal to lexer.close curly, then we do p.expect lexer.comma, like so. And there we go. This is now the parsing for array instantiation expressions. I can clearly see I'm not using this, so let's go into the lookups.go. And here, right where we have call, member, and arrays, right here, we're going to just do a nud of lexer.open bracket. I'm going to pass this in like so. And there we go. If we run this, look at that. It's beautiful. So we get variable declaration, variable name of numbers. It is constants. The assigned value is an array instantiation expression where the underlying type is number and the content is 1, 2. Now let's just quickly test this. Make sure that we can add a comma here. Sure enough, we can. That's always nice. And let's make sure we can make this a complex type, like an array of number. And sure enough, we get the assigned type, where the underlying type is an array of number. Beautiful. So that seems to be working just perfectly. It can also be empty, so let's double check that. And so there we go, contents is nothing. The explicit type is nothing, right? Because we don't specify anything, so let's make sure we can. And there we go, right? So we can see how very clearly we're able to start parsing some really cool stuff now. Right, so I'm going to just leave it at this, and that is it for today's episode. I hope you found this video useful, and in the next episode, we'll be working on some more parsing for our language. Please like, comment, and subscribe, and if you have any questions, feel free to leave them for me in Discord, which will be linked down below. In the meantime, happy coding. I'll talk to you later.